Hello students, how are you? I hope you are well and safe at your home. I welcome one more time all of you on this educational platform. In today's session guys, we will discuss about the different previous year's questions of periodic table. In the last few lectures, we have studied about the entire periodic table as far as the theory is concerned. Now we shall see what type of questions have been asked in the past years from this topic. So we will discuss few questions from Neet examinations and few questions from JEE examinations. So let's come and solve these questions. So student, as I told you in today's class, now we shall discuss some previous year's question being asked from this chapter. So there are plenty of questions came in the examination in the previous years from this chapter. Now we shall discuss a couple of them. So the first question which comes here is the ions. What ions we have? O-2, F-, Na+, NMg+2 and Al+3. They are isoelectronic, means they have same number of electron, yes, and their ionic radii show. Now four options we have, and increases from O-2 to F- and then decreases. First decreases from O-2 to F- and then increases. A significant decrease from O-2 to Al+3, or significant decrease from O-2 to Al+3. Now if you draw all these species, O-2, F-, Na+, Mg+2 and Al+3. Now you see students, in these species, as we move left to right, Z effective means effective nuclear charge increases. With the effective nuclear charge increases, obviously radius decreases. So what is the order of the ionic radius? Here the order of ionic radius shall be like this, in the decreasing manner, constantly decreasing. So the correct answer of this question will be a significant decrease from O-2 to Al+3. Fourth option is the right answer of this question. Now the second question is, what do we mean by ionic radii? So what is ionic radii? Student, when any atom loses electron and form ion, whether it is cation or anion, that is called as ionic radii. Now as you have just seen in the previous question, that in the ionic radius, if the effective nuclear charge increases with the increase in the effective nuclear charge, obviously attraction of the nucleus to the outer electron increases and definitely radius will decrease. So ionic radii, whether it is a cationic radii or anionic radii, see, it is inversely proportional to 1 upon effective nuclear charge. For the more effective nuclear charge, ionic radius will be small. So this relation is inversely proportional. This relation is inversely proportional. So effective nuclear charge is inversely proportional to the ionic radius, and answer of this question, which was being asked in All India Pre-Medical Test 2004, is option number 2. Now the another question. In this question, examiner asks, what are lanthanoids? So students, do you remember what are lanthanoids? What do you mean by lanthanoids? Where are they? If you remember, in this raw format of the periodic table, if we draw the raw format of the periodic table guys, this one is S block, if you remember. Here it is P block, and in the middle it is D block. But in the D block, after element number 57, which is lanthanum, from 58 number cerium to 71 number lutetium, these 14 elements are placed in the 4F series, in which 4F subshell is filled, and they are member of F block. So what is lanthanoid? 14 element in the 7th period? No. 14 element in the 6th period? No. 14 element in the 7th period? No. 14 element in the 6th period? Yes, the period is right. See, in the option number 2 also, period was right, but atomic number was wrong. Atomic number should be 58 to 71. You know guys, this 90 to 103, this is the atomic number for actinoids. So right answer of this question is option number 4. Period number 6, atomic number 58 to 71, just after lanthanum 57 are called as lanthanoids. Then next question. Next question says, which one of the following arrangement represent the correct order of electron gain enthalpy? Of course with a negative sign. See, electron gain enthalpy is what? What is electron gain enthalpy? If you remember, I taught you in this chapter that electron gain enthalpy is the involved energy. Student, it was involved energy when electron is added. When electron is added to an outer shell of isolated gaseous atom, that energy is called as electron gain enthalpy. Now, if you remember that electron gain enthalpy decreases down the group, but exceptionally member of 3rd period have more electron gain enthalpy than corresponding member of the 2nd period. So technically chlorine has the more electron gain enthalpy than fluorine, and sulfur has more electron gain enthalpy than oxygen. So electron gain enthalpy of chlorine is greater than fluorine, and electron gain enthalpy of sulfur is greater than oxygen, despite they belongs to 3rd period, but still it is more as an exception because of the high electron density in the member of 2nd period. So this order is chlorine is having more electron negative gain enthalpy than fluorine, and sulfur is having more electron gain enthalpy than oxygen. But what about the comparison of chlorine and sulfur? See, electron gain enthalpy increases as we go left to right. So electron gain enthalpy of halogen is of course more than the oxygen family. So the correct order will be chlorine being the highest electron gain enthalpy in the periodic table, then fluorine, then after sulfur, and in the last oxygen will be there. So the correct order will be option number 1, no. Option number 2 is wrong order. Option number 3 is correct order. And of course option number 4 is also wrong order. So right answer of this question is option number 3. Please note down. Now here comes the next question. 4 successive members of the first 2 transition elements are listed below with their atomic number in these options. Which one of them is expected to have the highest 3rd ionization enthalpy? First, do you remember what is 3rd ionization enthalpy? If you have any gaseous atom and you remove 1 electron, formed M+, this is IP1. But if you still remove 1 more electron, it is M+2 and it is IP2. But if you remove 1 more electron from here and you tend to form M+3 ion, then this energy is called as IP3. So in which case IP3 is maximum. Now you see, you think about the manganese. Manganese atomic number is 25. So what is the electronic configuration? The outer electronic configuration of manganese is 4s2 3d5, right? Now if you remove 2 electrons from manganese and you form manganese plus 2, if you remove 2 electrons from manganese and you form manganese plus 2, then its configuration will be 3d5 4s0, and this configuration is stable. Why it is stable? Due to half-filled structure. D subshell is exactly half-filled, as it maximum it can contain 10 electrons, so D5 is exactly half-filled, and we know that stability of half-filled is greater than other configurations. So it is difficult to remove electron from 3d5 configuration, as it is a stable configuration, and as a result it will be quite difficult to remove 3rd electron from manganese. So the right answer will be manganese, because in this, after removal of 2 electron, it will attain stable configuration, half filled D5. Now the next question is, which of the following is most basic oxide? It is very simple question, students. Which one is most basic or alkaline? This question was there in All India Pre-Medical Test 2006. So what about the nature of oxides? See, I taught you in the periodic table that for the oxide, if you go left to right in periodic table, their acidic nature increases and basic nature, means alkaline nature, decreases. But if you go top to bottom, down the group, if you go down the group in the periodic table, for oxide, obviously for oxides, then their basic strength increases and their acidic strength decreases. So here we go. Basic strength increases, acidic strength decreases. So down the group, maximum basic character is there. That is why the right answer is Bi2O3, bismuth oxide. This is the right answer. This is the most basic oxide in this question. Here we go with the next question. This question was there in All India Institute of Medical Sciences Entrance Examination 2014. It says the electron affinity of halogens. Which of the following is correct? In these four options, we have four different orders of the electron affinity for halogens. Now it is asking which one is correct. First option says bromine has more electron affinity than fluorine. No. Fluorine is having more electron affinity than chlorine. Actually, it should be. Fluorine should have more electron affinity than chlorine. But if you remember, students, as an exception, electron affinity or electron gain enthalpy of third period member is greater than second one. So chlorine has more electron affinity. So this option is also wrong. And electron affinity of chlorine is maximum in periodic table. So bromine cannot have more electron affinity than chlorine. So this is also wrong. And the right answer is option number 4, which says electron affinity of fluorine is greater than iodine. This is correct answer. Now another question. See, now this question was there in IIT Joint Entrance Examination 2001. In this question, it says moving from, it says right to left. Please pay attention, it is right to left. Normally we study parameters left to right. But here it is not left to right. Here it is asking right to left. Right to left in the periodic table. Atomic size. Now we know that left to right in the periodic table, atomic size decreases. So if left to right atomic size increases, what will happen right to left? In this case, definitely atomic size will increase. So the right answer for question number 8 will be first, increased. The right answer is increased. Alright, now here comes the next question, which belongs to Joint Entrance Examination 1995. This question says the increasing order of electron negativity in the following element. See, it says electron negativity. So first you try to memorize what is electron negativity. What do you mean by electron negativity? Students, if you remember, electron negativity is the tendency of any species to gain or to attract the shared pair of electron in the covalent bond. So in the covalent bond, shared pair of electron is there, and tendency to attract that shared pair of electron is called as electron negativity. So what is the correct order of electron negativity? We know moving left to right in the periodic table, electron negativity increases, and going down in the periodic table, electron negativity decreases. So following this trend, This is the right answer. Silicon, phosphorus, carbon, and then nitrogen. This is the right order for electron negativity of these elements. Option number C is the right answer. Now another question. This question was there in 2015. It says one element has atomic weight 39. Pay attention. Atomic mass of any element is 39 and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. What is the true statement for that element is? First we have to identify the element. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So how many electrons? Students, it has 19 electron, and for 19 it will be potassium. So actually this is potassium we are talking about. Now this is the electronic configuration of potassium. Now we have to select the true statement for the element which is potassium. Now high value of IP, no. For alkali metals value of IP is less. It is transition element, no. Potassium is not transition element. Potassium is a S block member and it is alkali metal. It is not transition element. Transition element belongs to D block. Is it isotone with organ 38? Student, what is isotone? You tell me what is isotone. Isotones are those which has same number of neutrons. Those which have same number of neutrons. Now we are talking about 19 potassium 39 in which protons are 19 and proton plus neutron are 39. So there will be 20 neutrons in this. But what about organ? 18 organ 38. Here number of protons will be 18 and proton plus neutron is 38. So there will be again 20 neutrons. So yes, they are isotone. They have same number of neutron. So they are isotones with each other. So the third answer is the right answer. They are isotone with the 18 organ 38 is the right answer. Alright. Now the next question. The number of paired electron in oxygen atom. What do you think? How many paired electrons are there in oxygen atom? In order to get answer of this question, first we should write the electronic configuration of oxygen. For oxygen, atomic number is 8 and the configuration is 1s2, 2s2, 2p, 4. Out of these 1s, this exactly look like this. In this 2s, the condition is like this. But what about 2p? As per the Hund's rule of maximum multiplicity, we cannot form the pair until each orbital of the subshell will not receive the single electron of same spin. So 2p4 will be like this. So these two electrons are paired, these two are paired, these two are also paired, and these two are paired. Yes, these two electrons are unpaired. So out of the 8 electrons of oxygen, 6 electrons are paired. So the right answer will be option number A, 6 electrons. Right. Another question. This question is theoretical question. It was there in 1997 joint entrance examination IIT. In this question, examiner is asking incorrect statement. Please do remember, you have to pick incorrect statement, not the correct one. First ionization potential of Al is less than of magnesium. Yes, it is there. First IP of Mg is more and Al is less. And the reason is, what is the reason behind this? And the reason behind this is penetration power. Reason behind this is penetration power. So because of the penetration power, first IP of aluminium is less because here we are removing electron from P subshell, while in the Mg we are removing electron from S subshell, and it is difficult to remove electron from S subshell. The second statement says second ionization potential of Mg is greater than second ionization potential of sodium? No. For sodium, after removing one electron, it will attain inert gas configuration. So students, please take note of that. It will be quite difficult to remove second electron of sodium, and second IP of sodium will be much greater than second IP of magnesium. So the right answer is option number B, because it is incorrect statement. This statement is not correct. And in this question, we have to pick the incorrect statement. The another question is, it was there in JEE 2000. Electronic configuration of element 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. It represent is this ground state, or is this excited state, or this is what? See, the configuration is d5 4s1. It is not possible, because if d5 is there, then there must be 2 electrons at least in the 4s subshell. So this should not be done. This is possible only when it is cation, because 4s is filled before 3d. So 4s always contain 1 or 2 electron, but here in this example it is containing only 1 electron. So it is only possible when this electron is being removed, and if this is being removed, then it means it is cation. So the right answer is, it is representation of cationic form. This is cationic form. Now the another question. This question says, which one is the correct order of radius? So what is the correct order of radius? Students, we know that going left to right, radius decreases, and going top to bottom, radius increases. Now if you check the first option, it is nitrogen, beryllium and boron. It says boron is bigger than beryllium, which is not done. So this is wrong option. This is not correct option. This is wrong option. Option number 2 says F minus, O minus 2 and N minus 3. Now if you pay attention, this F minus, O minus 2 and N minus 3, they are isoelectronic. 10 electrons are there. Here also 10 electron, and here also 10 electron. In the isoelectronic series, when we go this side, Z effective decreases and size increases. So the correct order of size is nitrogen, then smaller is O minus 2, and then F minus. So this is the right answer of this question. Students, in the isoelectronic series, they are member of isoelectronic series. You can also do one thing. For isoelectronic series exclusively, Z effective can also be calculated by the use of number of proton upon number of electron. If you divide the total number of proton by total number of electron, then you will get Z effective, and Z effective is proportional to 1 upon radius. So here you can calculate the order of radius for all members of isoelectronic series. Another question. The set representing correct order of first IP. This was question in 2011 IIT JEE. So which one is the correct order of IP? IP1 specifically, first ionization enthalpy. Now when we go left to right, IP increases as size decreases, but IP of second A becomes greater than third A, and the reason being penetration power. It is difficult to remove electron from S subshell rather than P, because it is more closer to the nucleus. And also there is an exception in the group 15 and 16, nitrogen family and oxygen family. Because of the P3 configuration of nitrogen family, their IP becomes more than the 16th member corresponding. So in this question, correct order of ionization enthalpy, first IP will be Option number 2, where beryllium is the maximum IP, it is greater than magnesium, and of course calcium is smaller because it goes down the group. Calcium, from magnesium to calcium, we go down the group and IP decreases. So this is the correct order of IP for group 15 elements. And students, these were few questions we discussed from the previous year examination, and I hope you understood these questions and you like the today's class. Keep coming and keep studying. Now we shall start the new chapter, that is chemical bonding and structures, that we will continue in the next class. Thank you.